Good afternoon, everyone. Hi, let's begin. Thank you, everyone, to attend this pretty late session. And I know some friends have already on their way home. And so this content slides I have presented in about 1 month ago at Berlin, but this time I updated them with new data and some new interesting things. And the content needs some background about the Kata containers and maybe gVisor. I'd like to ask all the audience, if you have some experience or have some knowledge about the Kata containers? Cool. Thank you very much. And so I will have the 3 parts. And first is to just a brief introduction about the Kata containers and gVisors, and then the comparison on architecture, and then do the main part is about the benchmarks. And I know you will have many challenges to me for the benchmarks. And I think since all of you have some background about the Kata containers project, so I may have the first part go through quickly. Yes, and this is hot, right? Just 40 minutes ago, in the previous session in this room, I take this picture, and yeah, the Firecracker is pretty hot. So I will mention a bit about it, but that's not my main content. Yes, about Kata containers. Yeah, it's a container runtime, just like runc. You can call it through the container, through command line, just like runc, as from Docker and something else. But the difference is that's virtualization based. So from the host side, it's like a VM. Hey, I think you have go on your way home. And about gVisor, yeah, that's like runc too. And also it's another thing for isolation, and it's a user space kernel actually. And that developed in Google for years and open sourced in about 6 months ago, just in the previous KubeCon in Copenhagen. And yeah, that's implements Linux by in Linux. Yeah, and both are very similar. They run on top of Linux, APIs, and also provide Linux APIs to the container. But there is a black box inside, in the middle. That's Kata and gVisor, the different part. From the architecture view for gVisor, that's pretty easy. That's an all-in-one binary. When you have built it, you have only one run IC, and you launch it, it will run in different processes. But one all-in-one binary looks pretty easy for use. And also they have a Sentry as a user space kernel here. Yeah, and there is another process for the file system I/O, and yeah, I think you all know this a bit. And for Kata containers, and if you have installed 1.4 of the Kata containers, it's a bit complicated, but actually you just call the Kata runtime, and every other things called Kata runtime here, and other things are created automatically. But when you do the PS, that looks a bit complicated. But yeah, from the version 1.5, So we make these things simpler. And if you use the containerd and with shim v2, you can have much cleaner like this. And later for the cryo, we have the similar way. About the architecture, and here the container applications will run in the VM-based sandbox, and yeah, we can have some vhost user for the fast user space I/O, and the vhost in the kernel part and the pass through and all kinds of the I/O support that's VM supported. And for the isolation part, that's 2 layers of isolation. The first is the bottom one is about the host and the guest. It's protected by the hypervisor, and the second is the ring protection between the guest kernel and the container applications. So the 2 levels of isolation. And yes, we have Cumulite default by default. It's the VMM here, and also we are working on enable Numio, a much simpler one, much simpler VMM as the hypervisor. Also, we are just do some research, and we have a simple POC to run the container with the Firecracker. Yeah, only 2 weeks time we have, but some Kata folks have done this dramatically. And a bit different from the gVisor side. The gVisor side also have 2 levels of the isolation. The first one is about this one to the host and guest, the ring protection, and the other one is a small site of the Linux API that's implemented with the Go language. Yeah, that's very thin layer, and yeah. And as far as I know, the gVisor team, the idea is the most frequent call paths of the Syscalls are quite stable and secure, but the last call maybe have some bugs there. That's most of the exploits that go through that the less frequently called syscalls. So avoid call them through the here, and some syscalls relies to the host to implement, and others they could implement. They could do the interception and then forward the syscalls back to the sentry, the user space kernel, and implement them. So have better security than only run the namespaces. And based on their research, they think the most of a major part of the compromise has come from the file system and the open operation. So they use a separate process to do the file system access part to ensure the isolation. And as far as I know, they told me the performance is not their first thing in their consideration, but the security. And one more thing is about the gVisor platforms. The gVisor, the open source version of gVisor currently support two platforms that in the Syscall interception part, they use either ptrace or the KVM. And here I want to say the KVM is just a tool they use to intercept the syscalls. it's not for VM level isolation. So that's not the isolation part, but only for the Syscall interception. And the other part, they are the same with the ptrace part, except use the KVM part that will be a bit faster in bare metal case. And later I will have the comparison with some data. And from the architecture, we can think both of the two runtime include the two level of isolation, and they will be have better isolation than runC. Yes, and I mean better, that's not absolutely secure. Yeah, for the secure things, you can have something better in architecture, but not for the single CVEs. Yes. And for compatibility, Kata should be better because the gVisor is another runtime, another user space kernel. But for Kata, we use a Linux kernel inside. And for the performance side, both should have very little overhead in CPU and memory, especially for the CPU part. The modern CPU will run very fast for the virtualization, but for the I/O part, that may different. And the gVisor, because gVisor is a microkernel that's written in Go, it's a very, very small. So gVisor should have smaller memory footprint, and because it's smaller and maybe boot faster. But gVisor may get some performance penalty on the Syscall heavy, such as the I/O or maybe other things, and many logs that may lead to some drawback on the performance. And Kata have really have some I/O optimization ways. So yeah, cool. I use 10 minutes to pass all the general parts, and later I will go through some data, share the data with you. I know you must have questions about this part. And about the benchmark, that's functional parts is about the Syscall coverage and some other things. And the standard benchmark include boot time and memory footprint, CPU and memory performance, and I/O performance, and networking performance. Also, we introduced some real-life cases to test how this different performance occurred in the real life, such as the Nginx, Redis, and Tensorflow. We also tried some other cases, but for the compatibility issues and some cases not suitable for the comparison, such as the MySQL and Jenkins all failed, and looks like I don't know what they done in the Git clone, but that failed. Yeah. And the test setup here is about the bare metal deployment. We use the instance from the package.net, and so we pay for this, and they didn't donate for this test. And for disk I/O, we use some more powerful server that have more disks for the test and for more cases. And also, actually, we have some virtual machine instance from the Google Cloud to do more tests for the nested part. And most of the test containers have 8 gigabytes memory, if not no further note. And for networking test, we have a client and a server, and just for the real life. Yeah. Yes. For the Syscall coverage, we test with different cases, and for gVisor, we read the code, and because the code is quite small, so it's pretty easy to find. They only call about 70 syscalls, and for Kata, it's pretty hard if we try to grab the syscalls from Qmil or something. So we just do the trace for different cases, a bit different. So they call about from 30 to 50 syscalls in different cases, and actually both the different cases, they will restrict the access from the guest to the host to a small set of the syscalls, and most of the syscalls will be processed by the guest kernel, either in VM or in the user space kernel. And so for the memory footprint test, we use a relative small size of the container, and to test with the memory. And for there's two cases here. The first, the blue one is just to launch a single container. Then we can see it's about 3 times of the memory footprint compared to Kata Containers with the gVisor. But we introduced some dark technology called template. Then after we enable template, and if we launch 25 containers and calc the average memory footprint, then we will be closer. Yes, I guess if we run 1,000, that will be much closer. And yeah, so the template itself is try to do the copy on write on the same part of the memory. Also, I may enable the KSM. So if we enable the KSM for the virtual machines, that will save much memories. But what I like to say for gVisor, they can save the memory out of box. So for memory footprint, I think the gVisor should be better here. And in this morning, there is a session about security, I think, or maybe this noon. They talk about for the Kata parts, said about some CVEs of the Qmil that implies the Kata is not safe, but actually most of the CVEs from the Qmil is from the last code part, and from what we use, we always configure out that the debuggy part. That's almost always true for the either the kernel or the VMMs or others. The major part of the bugs always live in the less frequently called parts, such as some legacy devices, such as floppies, and maybe some card, some blaster card. Maybe I think that 20 years old devices and some serious VGA adapters. I never seen a real serious VGA adapters, but I saw that in the virtual machines many times. But for Kata, we never use such devices, and we just configure them out. And later, when we change it to NewMill, and there's further less of the devices. And for the Firecracker, in the same way, they have no device model, so there will be much lighter bugs about this tricky part. So about the boot time, yeah. I show many different configuration of the Kata containers that show if you to not only be to do the comparison between the different runtime, but also for the different configurations. Yeah. And for the left, right, yeah. For the left figure, it's about the bare metal test. For bare metal, we can see the best case for the Kata containers. That's pretty similar to the runc, but the gVisor is even better. Yeah, and the worst thing is to just call the command line and without any feature enabled. But for 1.5, we have when we use the shim v2, that will be much closer. And for the nested part, that means we launched the test in the GCE instance, and also we can have better performance when we enable the template. But in this case, we have some gap between the Kata and the runc. Yeah. We will dig into the difference in the later test. Yes, the memory performance, and just for the bare metal test, or either the bare metal or the nested. I didn't list the CPU performance here. Just one sentence. The CPU performance, there's no difference between any of the runtime and for any of the cases. So I don't think it need to plot a straight line here. But for memory, it's quite interesting. Yeah. For bare metal case, we see the performance of memory access that's quite similar, especially for the random write. But for nested virtualization, right in the VM, we can see some performance penalty for the nested virtualization, for some page table things. But for the gVisor, if you use the gVisor ptrace platform, there is no nested virtualization here, so there's no difference on the memory performance part. But that doesn't mean the gVisor will have better performance in every area. But if you talk only about the memory performance, the gVisor in the nested case looks pretty good. And do I/O performance. When we do the I/O performance, firstly we use the FIO to do the I/O performance, but unfortunately the gVisor can't complete this test. I don't know which Syscall failed, but it's failed. And if we pass through a device directly into the Kata containers, and because of the Kata kernel enable the multi-queue directly by default, but that doesn't apply to the host. That's because the host OS, that's the OS level difference. So we have better performance than the host OS, just because we pass through the device into it and use the driver with multi-queue support. And we have to make some tests with gVisor. So we try to use the DD, the DD command, and to do some DD test with the 9P, and also with the gVisor and the Kata containers. One thing I'd like to say, the 9P, if you use the 9P, natively 9P is kind of the network file systems. Then it's include a client and a server. So if you specify I want to use the direct I/O in the client part, but in the server part you can't configure it to use the direct I/O. So for the networking for the I/O part, this implies the cache is here. So even with cache here, this shows some different on the performance, right? And for the small piece of the read write, this is the gVisor have many performance penalty here just because the I/O introduced many syscalls, so the performance get down. And for networking, yes, we tried different configurations, and we see I selected one configuration to make the gVisor performance, to maximize the gVisor performance here. But unfortunately, I think this is also means because of the penalty of the syscalls, so you can't have good performance for the gVisor's networking part, but others, the Kata and the runc and the host, quite similar. Please.
Which protocol were you using for the network test?
Yeah, the networking test here is use the iPerf and mainly for the TCP, and it's in the local area in the LAN test. So I don't think there will be many things because of the congestion control mechanisms. But we do check the net states and some data. There's no package loss here, so I think that's fair. And also we may introduce some UDP tests and other tests. Yeah. Yeah. So we try to have some real life tests and to matrix what's the different data before means for the real life. And the first case is about to run Nginx with runc and the gVisor and the Kata containers. And this is about this is the general result about the Nginx test. So I think only one line is this line is about the data rate, and there should be a time per request. Looks like the average time, and here for the Kata and the runc, they are quite similar. And here is a note: we didn't use the 9pfs for the Kata test. You know, if you use the Kata, use the 9p, and the 9p will introduce some penalty here. So this implies some suggestion for the production usage. If you want to have better performance, try to avoid use 9pfs. And here's some detailed data. Yeah. And this is about the orange line is about the Kata, and this line is the runc. Almost all the percentile of the requests are the runc and the Kata are the same. But it looks like the last request, the max ones, the Kata, I don't know what happened, but we repeat many times. There is one request that lasts for 200 milliseconds, and I think that looks there is some they made some issues on the fire scheduling things. But we will dig into it later. And for others, quite similar. And you know the gVisor is quite smooth, but not really fast. Yeah. And so here is some interesting part. Redis. You know the Redis mixed two things about the networking access and the memory. So people always use Redis as a rich semantics of the memory cache. So there is heavy memory operation behind the Redis. So you may think try to recall the previous page about the memory things, and so here is the benchmark for the bare metal. Yeah. For most of the different operations, and on the bare metal, the Kata has maybe have some gap in some of the operations, but in others are quite similar. At least they stand at the same levels, right? But gVisor looks not so good. I think that's mostly come from the memory part, yeah, from the networking part, yeah. That's because the networking of the gVisor in other tests shows not so good. So the next slide must be about the nested virtualization part, yeah. The middle one too is about different configuration of Kata, and the first is runc, the blue is runc, and the yellow one is the gVisor. So go back, come again. So this shows in the VM, in the nested virtualization, we may have some performance penalty on the memory part for the Kata, and have the performance penalty on the networking part for the gVisor. Yeah, no one is perfect. It just depends on which one is worse. Yeah. So interesting, and this shows what we should do the improvement. Yeah. So another test is about TensorFlow. This is pure CPU test, no GPU here. Yeah, we're working on the GPU support integration, but here the test is only for the CPU test. And this shows either the Kata and the gVisor looks like pretty similar. Yeah. So this means this test is almost purely a CPU-bound test. So no significant difference between the different container runtimes. And here I can summary. Both the Kata and the gVisor, they have small attack interface. They use very small, a small set of the syscalls for the host, and they have the second level of isolation. So they have small attack interface, and they have better isolation than runc. And also the CPU performance is identical to host and runc. So if your application is a pure CPU bound test case, such as the TensorFlow or something like the FFmpeg for the coding, encoding and decoding, all these cases are quite similar. They have the quite similar performance. And for the Kata containers, use the device pass-through may have better performance. And when we enable the template and the ShimV2, they have better boot time and the smaller memory footprint. And also, in most cases, we have a good performance. But in the nested virtualization mode, we will meet some performance penalty on the memory side. This should take care about. And on the gVisor, yes, the faster boot performance and low memory footprint. But the compatibility is not really good, such as the MySQL and Git clone and FIO all failed. Looks like some particle semantics will fail. And But there's no nesting performance penalty if we use the ptrace platform. Yes, ptrace itself is slow on the Syscall interception. In any case, the ptrace is slow, but it will play identical when you do in the virtual machine or in bare metal. I'm not mean the ptrace has good performance. Just mean no penalty on the nested virtualization. So maybe this is a continuous project on the benchmarks. So the good thing is maybe I can present in the next conference, and we will have more fine-tuned case benchmarks, such as enable vHouse user for the Kata on the network side, maybe for the 40 giga, and for some other NUMA-specific tests, and also we may introduce the Numio and the Firecracker in the later test, and also some different kinds of networking tests include the UDP case and the TCP case, and if there is some package loss, and maybe do other advanced filtering of the packages, and also have some more real-life cases. Actually, we have some new cases. I didn't put them into the slides just because we have limited time, and we just want to find some very signature tests. So about the future for Kata containers, we have the ShimV2 part I have already merged and already in 1.5 RC1, and it will release in 1.5. And also the Numio is introduced to reduce the VMM overhead. Also we are thinking about Firecracker, and also we will have multiple networking improvement. Also for the better GPU and other accelerator support. So this is right now we are pretty mature project, but contributions are very welcome. So we are now open project. And on the Firecracker part, yes, we have done some tests from that gentleman. So he have already have a POC to launch the container through the Firecracker and from Kata. We have done that. The good part is the Firecracker have fewer code and written in Rust. That implies it's small and may launch fast, and it doesn't have the device model, so it's lightweight, and also it's from AWS. That means it's when it's born, it have a large user set and help it to become mature. That's the good part. And the not so good part is for Firecracker, there's no hot plug yet. But regularly the Kata depends on hot plug to insert the containers into the pods, and this is what CRI have, and so maybe we need to do more work about this. And the gVisor shows it's lightweight and run fast on the not really fast. It's no nested virtualization. So and gVisor may need more work on the better compatibility. And also we have another project that's based on the Linux kernel and doing the similar to the gVisor. And we have a presentation in Vancouver, I think, on the end of August. So if you have interest, you may have to take a look. And so that's all. I guess you just want to challenge me by some data. So, any questions? Please.
Do you have any future, or do you have any idea about future works about security?
Security?
Security type of perspective, because you, you mentioned about that, performance.
Yeah.
But actually, I want to hear about
Yeah. I think you mean about the test for the security part, right? Yeah. We did do some security phased tests, include some CVEs and some others. And not so easy part is about if we try to do it with some CVEs, that means the CVEs has been public. And if a CVE is public, then it is fixed in the mainline. So that's pretty hard to make it automatically tested, but you can do some manually tested. I have posted some demo video on YouTube to showcase some CVEs in the just to compromise a runc container, but for Kata containers that stop it. It looks like it's pretty like a demo. you cannot tell this what I do behind. so I didn't put it on the slides, but really we have to do some about tests, and we also think about how to have a better security test, and any suggestion is welcome. Thank you. Yeah. Thank you.